Okay, we're taking a look at 2013 question 3b. So a plane is inclined at an angle tan inverse half to the horizontal. A particle is projected up the plane with initial speed u at an angle theta to the inclined plane. The plane of projection is vertical. The line contains the line of the greatest slope. Find the value of theta to give maximum range up the inclined plane. So first off, like always, I would draw this. So let's have a quick sketch. So we've got a plane. Oopsie doodle. We've got a plane. We have this angle in here, which we're told is tan inverse of a half. And we're told a particle is projected up the plane. So it's projected up the plane, and it is projected at an angle theta. So it's projected with a velocity u. And I like to just draw on this one here. I'll change the color just to show it. Let's talk about its acceleration. Okay, so there are two, we need to resolve it to the plane. So this angle in here is going to be tan inverse a half. Okay, that's always relative to the plane. If this is minus g, then this side is minus g cosine alpha, and this side is minus g sine alpha. And by alpha, I obviously mean theta, so I'm just going to change them up so I don't be getting silly. So theta and... Oh no, sorry, what am I saying? No, I was right the first time. Get out of 10. So I'm going to say, instead of that, I'm going to say of the angle, and the angle is tan minus 1 of a half. You can plug it straight in because you know it. Tan minus 1 of a half. Oopsie doodle. Okay, so we're just plugging that in to show it here. Over here we've got our u. I might as well do this on the graph while I'm here. So in the I direction, that's going to be u cosine alpha. I keep saying alpha. What's wrong with me today? U cosine theta. And over here in the vertical direction, that's going to be u sine theta. Okay, because it's opposite. So just filling in all the major details there to get me started. Let's take a look back at the question because I've already forgotten. Find the value to give a maximum range. Okay, so we're looking for the max range, right? So range is referring to where it lands over here. We call this or. So just to remind ourselves, if this is the I plane and this is the j, then if the I, we're looking at the j, how much in height has it changed from here to the r? It's 0. So in the j, we've got 0. So let's do the j first. So we're going to say u, zoom in a bit more. Uj, Vj, Aj, Sj, T. And remember, the T is the same for both the I and J, and we're always trying to find the T. So the initial in the J is u sine theta. Okay. The final velocity in the J we don't really know. The acceleration is in the J, just be careful with this. It's this stuff we found over here. So in the J plane, it's minus g cosine the tan inverse. So I'm just going to plug that in my calculator now. Tan inverse of a half, and cos of that answer is going to give me something ridiculous. So I'm just going to take a moment and go over here and say, okay, cos, oopsie doodle, delete. You'll obviously have a calculator and can pause the video and do that. You know what? I'll just leave it for now. Can't be busy doing that. So minus g cosine tan inverse of a half. Okay, I'm gonna try it one more time. Now that I've figured out how to work my calculator, cosine brackets tan inverse bracket 0.5 double bracket. Cool, that looks wrong, so I'm just going to leave that alone for the minute. And then t. Okay, actually I'm going to show this here while I'm doing this because I've just to show how you can get this nice and quick. Sometimes your calculator won't spit it out nicely. The newer ones will. So I'll just take a moment to show how to do this if you want. If you take a triangle and you say, look, if it's tan and that's your angle, we'll call it alpha. Haha, finally get to use alpha. Then the opposite is 1 and this side is 2. So that means that this side would be 1 squared plus 2 squared. 1 squared plus 2 squared will equal x squared, I'll call it. So 1 plus 4 equals x squared, so x is square root 5. So this is square root 5. So then you could just put very simply cosine alpha would be 2 over root 5, and sine alpha would be 1 over root 5, opposite of our hypotenuse. So just very quickly, that will replace my this whole bit here if you want. So I'm just going to do that and just check it even on my calculator now. Yeah, I got the same answers when I did it. It's just ugly. So now I can say that this guy is minus g 2 root 5, 2 over root 5. So hopefully that makes sense. Which equals minus g times 2 over root 5. Okay. S in my j direction is 0. So now that I have all that, and it took a bit longer just to explain it, I'm going to use s equals ut plus a half at squared. So yeah, you can use your calculator and you can just do it till the very end. It'll work out. But my calculator is a little bit older and it was just giving me ugly decimals. So it's just like, here, I'll do it properly now. So this is u sine theta t minus a half g 2 over root 5, forgot that little bit there, times t squared. So just to show here, the 2's will cancel nicely. And I'm going to get t times u sine theta minus 1 over root 5t equals 0. So that means t equals 0, or u sine theta minus a fifth t equals 0. Again, anyone who watches these videos knows how diabolical my pen is, how moody, how much it likes to change its mind. So apologies for my scrawled writing. Hopefully you're hearing it over and it might make sense. So, right, hopefully we can see that t equals u root 5 sine theta. Okay. Just going to check I didn't drop anything. I did. I knew I dropped something. There was a g here. So there's g here. So there's a g here. Hey. So this is gt equals that. I just knew. I'm always suspicious if I don't have a g at the end. I'm like, wait, I just forgot something. There we go. Okay. Happy days. Whew. So we've got that far. We got t in terms of theta and g, right? So now we've looked at the j direction. We need to take a look at the I direction. So in the I direction, let's write down what we know. So ui, vi, ai, si, and t. So we now know that t is that stuff I just found there, which was, I think I remember, as u root 5 sine theta all over g. My si is my range, which is r. My acceleration is this guy here, minus g sine alpha. So this is going to correspond to this guy, okay? So that's going to be 1 over root 5. So minus g 1 over root 5. So I'll just plug that in now. Minus g times 1 over root 5. My velocity I don't know, and my u is my initial, which is u cosine theta. Okay, cool. So, exact same again. We're going to make an equation with s. So I'm going to say s equals ut plus a half at squared. S equals u cosine alpha times t, which is u root 5 sine alpha, or sine theta all over g, minus a half times 1 over root 5 g times u root 5 sine theta all over g, and don't forget that's all to be squared. Just double checking. Yep, I put in my right value there. So now just to clean this up a bit and then talk, what the hell are we doing? Great question. So we're going to end up getting s equals u squared root 5. Sorry, s, if we remind ourselves, was actually r, so I'm going to change that to an r for range. Okay, u squared 5 cosine theta sine theta all over g. Minus, now just let's take our time with this, minus this becomes g over 2 root 5 times, and I'll take my time, u squared times 5 times sine squared theta all over g squared. Okay, let's see if anything cancels. G cancels with the G squared. No, that looks like it's it there. Okay, so let's just clean it up and then talk about what we have going on here. So we've got R equals ding 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 u squared square root 5 plus all this jazz G minus u squared 5 sine squared theta all over, that's a 5 there, sorry, 2 root 5 G. Now, hoi caramba, there was a lot to that, okay? And we're kind of stuck in a situation of we need to do something with this now. So, the question comes down to this, and the question is, what the hell do we do now? We've got range in terms of theta, okay, and u, right? Now, that kind of still leaves us with two unknowns, but what we do need to do is go back to the question. So the question said, find the value of theta to give the maximum range up the inclined plane. So what we need to remember is that when we're talking about max range, or max anything, when you see the word maximum, you're going to say, I'm going to differentiate the range, right, to get the max or the min. I'm going to differentiate it, and in this case, I'm going to differentiate it to the other variable I don't know, which is theta. And really that dictates, you're trying to say, what angle would I send this up to get the maximum? So I'm going to say at max min. So just before I differentiate it, let's look at some constants and maybe some things we can take out to make our life a bit easier. What do they share? Well, first off, I'm going to clean this up, right? So there's a square root 5 in the bottom. So if I multiply top and bottom by square root 5, okay, it's going to clean up this side in a moment. And I'll just show that. I'll actually take my time and show that. As well as that, they both share G, so that can come out. They both share a U squared, so that can come out. So we'll actually see in a moment, this should clean up pretty nicely. So let's just go clean this up before we differentiate it a bit more. So this side, this part of it is fine. Okay, all over G. Now over here, we're going to have, I'm going to multiply top and bottom by square root 5. So on the top, this become u squared 5 root 5 sine squared theta. And on the bottom, it would become 2 times 5, right? Because you'd be multiplying root 5 by root 5. So 2 times 5, g. So that become 10g on the bottom. So I'm actually just going to wipe that out and say 10g, and you can have listened to that, right? And I'm just going to, if that's 10g, right, and there's a 5 on top, then these guys are going to cancel, okay? And you're going to end up with 1 up here and 2 down here. So I'm just going to write that. Hopefully you watched the video and followed. If you didn't, shame on you. Okay, cool. Now it looks a lot nicer because they share a lot of things. They share a u squared, a root 5, and a g. So we're going to end up getting this. R equals, factorizing it, u squared root 5 over g times cosine theta sine theta minus a half sine squared theta. Okay, now I'm just going to double check a few things, and this is going to be a bit that might kind of leave you a little bit baffled. So we've got cosine squared theta sine theta minus a half sine squared theta. Can I go ahead and differentiate it? And the answer is you can at this point. If you want, you can differentiate it using, just be careful of your product rule, okay? And again, the product rule, well, your chain rule here, that is one way to differentiate it. You can also, if you go to your little, what you call them, log tables, get out of here, adverts, don't want adverts. I go to my log tables and I say, get the log tables, sorry, I'm just using an app here. You'll have your log tables handy. If you go to your trigonometric rules, so I'll just flick down until I find it. There's some here that can help you. Now, they're not super obvious, but from years of experience, I see them here. Do you see where it says here, sine 2 alpha and sine squared alpha? So you can use these kind of ideas here to help solve it. I'm not going to do that, and I'm sorry, I'm just pointing it out to you because that's where, if you're looking in the mark scheme, that's where they got these next rules, right? I'm going to do it by using the chain rule, or sorry, chain rule and the product rule. So apologies for the digression. So dr d theta, let's differentiate it. So I'll change color here. Dr d theta equals. Now, if you differentiate, remember, a constant just stays as it is, so I'm just going to leave this alone for a minute, and I'm going to multiply it by all that differentiated. So all this differentiated is, if I call this u and I call this v, it's a double check actually while you're here, checking your integration rules or your differentiation rules, and make sure you're not making silly mistakes. Going down to differentiation, your product rule is there, u dv dx, v du dx. Can't believe I had to check that, u dv dx. So it's going to be cosine theta by dv dx, so dv d theta in this case. So just check what's your sine when you differentiate it. Sine becomes cosine as well. So I'm going to get cosine, get rid of that, cosine theta. Okay, plus v, which is sine theta, by, oopsie doodle, differentiate cos, and you get minus sine. So this is kind of cool for what's about to happen here. Minus sine theta. Now I've only done, just to show and take my time, and again, hopefully you're listening because it won't make much sense if you're not. I've only done this part. That's the product rule. That's all I've covered so far, right? So, but let's see how that's going to clean up. We're going to see that clean up in a line. So I'm going to leave that alone. I'll leave the underline as well. Let's differentiate the second part. Okay. So differentiating this part, you're going to get... now, I actually find this easier to do if you were to break this up, and I'll just show it here for a side. I'm going to say it's a half sine theta by sine theta. This helps you avoid making mistakes, which a lot of students make. I'll put a minus in front just so we stick with it. If you differentiate this, you're going to get minus a half sine theta times sine theta. So it's going to be the product rule again. So if we call this u and call this v, we're going to get u sine by what sine theta is when you differentiate it. Sine theta is cosine. Always worth checking. I mean, I've been doing these years and I still check it. Okay, plus sine theta by cosine theta. Okay, so you end up getting minus, oopsie doodle, these add together to give you 2, minus a half by 2 sine theta cosine theta. And what's going to happen is you're just going to get minus sine theta cos theta. Okay, so that's the little bit I wanted to stress there. Plugging that in, actually I'll just do this if you don't mind. You don't mind, of course you don't mind. I'm just making videos up. So I'm going to say this ends up being minus sine theta cosine theta. Okay, and close that off. Right, I'm almost done. So we're going to get this whole bit becomes 0 equals. Now I'm going to take a moment and take a jump. You could, because this is 0 on the left, you can divide this side by u squared. You can divide by root 5, you can divide by g. So we're just going to be left with the stuff in here. So it ends up being cosine squared alpha, sorry, minus, get rid of that there, minus sine squared theta, sorry, they should be all thetas, minus sine theta cosine theta. And we're so close to being done. Okay, cosine squared theta minus sine squared theta. So let's jump to our log tables and check out our trig rules. I believe we might have seen this one or one similar already. Cosine squared minus sine squared, look at it there, it's cos 2. So this becomes cosine 2 theta equals 0. And can we do anything with this one here? So cosine 2 theta, and we've got sine theta cosine theta. So let's just have a look, see if we can do anything there to help clean that up. Sine theta cosine theta. Okay, cool. So just having a look here, it kind of looks like this second rule, but there's a 2 in front. So I'm going to half it. So I'm going to say it's minus a half sine 2 theta. Oopsie doodle. Get back on there. Sine 2 theta. Why am I doing that? Because now we've got sine 2 thetas for both. It's going to look nice. So I'm going to bring that over. That bit there, by the way, is probably the most challenging part of this question. Well, sorry, this whole question is quite a challenge. Sorry, you know about my pen. I've mentioned enough times. Great. Why am I rearranging this? Maybe you might see it already. I'm just going to say sine 2 theta equals 2 cosine 2 theta. And then I'm going to say sine 2 theta over cosine 2 theta equals 2. Hey, I'm feeling really good. You probably know what's going on here. Tan 2 theta equals 2. Happy days. So that means that 2 theta equals the tan inverse of 2. So go into your calculator, go tan inverse of 2, and then half it. So you're going to say theta equals the tan inverse of 2, all divided by 2. Divide that by 2. And hey presto, I get 31.7 degrees. Now I'm going to just briefly go through all that again, because I kind of went off tangentially, but I think it's pretty important. The key thing here is to firstly take your time to correctly draw your accelerations, then draw your u vectors. Okay, this part here is actually more important. I would use it for sure than using a calculator, because calculator, unless you've got a new one, it's going to end up being ugly. Find t in the I direction, then use that in the j direction, and then the really hard part of this problem really is this differentiation stuff that goes on here. And all it matters is taking your time. Okay, I took my time, I went through it. This part here, spotting the change of rule, is also really challenging. Okay, there are challenging parts, but if you go through these, you'll find like the same question comes up again and again. Anyway, I hope that helps.